Hey, so go ahead and put your name on here. It's currently second hour. You guys are going to turn this in today. This is worth a grade. It's essentially another assignment that covers all three different methods of solving. So 3.1 and 2, or it's actually 3.1 and 2, 3.4 and 5, 3.6 and 7. So we have these three different methods. It is most convenient to use graphing when both of our equations, so I'm just going to say both, we're talking about our equations in a system, are in slope-intercept. What is slope-intercept form? Guys, we spent a whole unit on this. Thank you, Cassie. Y equals mx plus b. So when both of your equations are y equals mx plus b. If you are just coming in, come get a copy of this, please. Okay. So it's most convenient to use graphing if both of them are already set up to be graphed. It is most convenient to use substitution if one of your equations or the other is either set up to be x equals or y equals. So x equals everything else or y equals everything else. Put away your Chromebooks if you have a Chromebook out. I hate that I have to say that every day. I've already said it once today. So one of your equations is x equals or one of them is y equals. Because if that is true, we are able to just plug that in. Matthew, put away your Chromebook. Okay, elimination. Elimination is easiest to use if both of your equations are in standard form. So standard form is that ax plus by equals c. So both x and y are on the left side of my equal sign. Okay. Any questions about either or any of those? I guess there's three, so it can't be either. Okay. So you could, with these graphing ones, you could set those equal to each other and substitute. With these substitution ones, you could convert them both to slope-intercept form and graph them. You could line them up and eliminate them. You could manipulate the equations and do any of these by any method. So like, if both in standard form, we could solve one and then substitute it. We could solve them both for y and eliminate or and graph it. But this is the easiest thing to do in each of these circumstances. Okay, the last thing I want to talk about before I give you the problems that you're going to sort and work on is the types of solutions that you might get from a system. So from a system, whether you are graphing it, solving it by substitution, or solving it by elimination, there's three things that can happen. If you are graphing a system that has no solution, what's going to happen to your two lines? How many times are they going to cross? None. So we're going to have two lines that happen to be parallel. If you are graphing a system that ends up having one solution, how many times are those two lines going to cross? One time. Your solution is that point they cross. You're going to write it as an ordered pair, x comma y. And then if you are writing or you're graphing a system that has infinite solutions, you're going to end up with the same line on top of itself. Alright. Let's talk about algebraically when we are solving. The most common thing that happens is we get one solution. That's what happens when we are able to solve for x and y. So if you're able to solve out for x and y, then you keep going. Your no solution and your infinite solutions are going to happen when our variables disappear. I'm going to put that on both of them. Variables disappear. Variables disappear. The difference is what's left. With no solution, your variables disappear and you are left with a false statement. With infinite solutions, your variables disappear and you are left with a true statement. Okay, I do want to also mention your variables disappearing is not the same thing as ending up with a 0. So let's say you get 5x equals 0. Your variables does not disappear. You still have an x there. You still need to solve for x. X is going to equal 0, okay? So being equal to 0 is not the same thing as all of your variables canceling out, okay? So it's only going to be one of your special cases if all of your variables cancel out. Any questions right now? All right, what's going to happen now is I'm going to come around with these colored sheets of paper, and you're going to grab one of them. You are going to get 6 systems of equations. Your directions for the rest of this assignment are here. You're going to cut out those 6 systems. That's why you have scissors. You are going to sort the systems by which method you think would be the best to solve them. And then you are going to glue them under the correct method and solve using that method. So use the first thing we wrote down here to pick which method is going to work best. There's 2 for each. So you're going to go through and you're going to say, okay, I need to find 2 systems of equations where both of them are in slope-intercept form. So you look through and you find those. I need to find 2 systems of equations where either one equation or the other is solved for x or y. You're going to put those down for substitution. And then you find 2 systems of equations where they're both in standard form. If you are unsure and would like checked before you glue and solve, please let us know. I'm not going to check everyone's, but if you feel like you need that, we can do that. They're on different colors of sheets of paper, so when you drop them, you can try to figure out who around you it belongs to, and if you have a different color than the person next to you. So, any questions right now? Okay, I'm going to pass these out. We're going to work on this for 20, 25 minutes. We'll see how long it takes you guys to get started and get working. I'm going to stop this video first, though. Bye, video.